All right, you guys, in this section, we're going to be talking about simplifying rational exponents, okay? So an expression with a rational exponent has a base and an exponent in the form of a fraction or a ratio, okay? So anytime you guys see the word rational, okay, that's a key word that you're looking for something that looks like a fraction. So anytime you see that, that's what they're talking about, okay? So what we're actually going to be looking at are exponents that are fractions, hence a rational exponent, okay? So when you're dealing with rational exponents, one of the important things is that you have to be able to convert it back into a radical expression. So we've talked about radicals a little bit. So this is going to be a way that we can convert back and forth. Okay. Another reason why that's important is because there are certain properties and things that you can do with exponents that you can't do with radicals. So for example, if we wanted to simplify a radical, we can't unless it follows certain conditions. But if we were to convert it to a rational exponent, we get to use all of our laws of exponents to simplify or solve a problem. Okay. So in order to do that, you have to understand how you convert from one to the other. Okay. So this expression here on the left, okay, this would be an example of an expression that has a rational exponent. It has an exponent that looks like a fraction, okay? This expression here on the right is something that we have that is a radical, okay? So we've looked at those before. So one way that you can remember to convert a expression with a rational exponent to a radical is a phrase that I like to call bow tie, okay? Bow tie stands for bottom out, top in, okay? So if you are dealing with an expression that has a rational exponent, okay, the denominator of the fraction, okay, becomes the index on your radical, okay? So bottom is out, okay? The numerator of your power, okay, becomes the exponent underneath the radical. So bottom out, top in, okay? So that's how you will convert from one to the other, right? So let's see if we can do some example problems. All right, so this first set of examples says to evaluate, okay? So right now for A, we have 16 raised to the 1/2 power, okay? So that's a rational exponent. That exponent looks like a fraction. So a lot of times we don't understand how to compute things with rational exponents in our heads because we've been so conditioned to do things in their radical form. So if you want to convert it to a radical, that's fine, and then you can simplify it. So 16 to the 1/2 power, if we were to write that as a radical, all right, I would write my radical symbol. 16, my radicand would go on the inside. So bottom out. So the denominator of my power becomes the index on my radical, and the numerator of my power becomes the power underneath the radical, okay? So saying that a number is raised to the 1/2 power is equivalent of taking the square root of it, okay? So maybe we didn't easily recognize that 16 to the 1/2 power, what its answer was, but we definitely recognize what the square root of 16 is, and it's 4, okay? All right, let's look at the second one. So B has us do 4/9 to the 1/2 power. So if I want to convert it to a radical, I'm going to write my radical symbol. I'm going to put my expression that goes in the radicand underneath it. All right, bottom out. So the denominator becomes the index on my radical. And the numerator of my rational exponent becomes the power underneath. Okay, so I have the square root of 4/9. Okay, guys, remember that anytime you have a fraction, all right, underneath a radical, okay, it's understood to be taking the radical of the numerator and the denominator separately. So the square root of 4/9 is equivalent to the square root of 4 over the square root of 9. We know that the square root of 4 is 2, and we know that the square root of 9 is 3. So our answer is 2/3. Okay, so not too bad. All right, let's see if we're right. So 4 2/3. Yep. All right, let's try these. So it says to evaluate again. All right, so if I'm going to convert these to a radical expression, okay, I'm going to write my square root. -81 will go on the inside. Bottom out, denominator becomes the index. Numerator becomes the power underneath. So they want me to do the square root of -81. And we know that that's not going to be a real number, okay? So this we're going to say not a real number. That would actually be imaginary. Okay. All right, let's try the second one. So for the second one, B, we have 25 raised to the negative 1/2 power. Okay. So I don't know if you guys remember your laws of exponents, but anytime you have a negative exponent, okay, you can make it positive by taking the reciprocal of it. All right. So if you have x to the negative, let's see, negative n, okay, you can fix it, all right, by moving the whole expression to the denominator. It makes your power negative, okay? So we're going to take that same rule and apply it to this problem. So instead of having 25 raised to the negative 1/2 power, I'm going to rewrite that as 1/25 to the positive 1/2 power. And then I can convert it to a radical expression. So it's still going to stay in the denominator under 1. So I'm going to have the square root of 25. Bottom out, the denominator becomes the index. Power on top becomes the numerator. So that's telling me to do 1 over the square root of 25. So that's 1 over the square root of 25, which is 5. Okay. So anytime you have that negative exponent, remember that you can use this rule to help you make it positive. Okay. And that rule works in reverse as well. If the negative would have been in the denominator, the power, you could have moved it to the top and it would have made the power positive.